All right, in this explainer, we're going to tackle a really powerful idea, one that connects the deepest processes of life with the absolute cutting edge of artificial intelligence. It's a concept called entropy riders. So let's just jump right in with a big question, one that might sound a little, well, a little strange at first. What could a living, breathing cell possibly have in common with a massive AI model running on a server farm? The answer, it turns out, reveals this hidden pattern about how complex things manage to survive in our universe.
And here it is. This is the core idea that unlocks everything else. The universe isn't some grand designer with a detailed blueprint. It's actually much more like a ruthless editor. It doesn't build things up from scratch, it just relentlessly deletes what doesn't work.
Okay, so let's really dig into this. Because before we can even begin to talk about AI, we first have to get our heads around this fundamental principle. This is the rule that governs pretty much everything from stars all the way down to single-celled organisms. Think about it this way. We often hear entropy is just about chaos and disorder, right? But it's also a filtering mechanism. Any arrangement of matter and energy that's unstable, it just falls apart. Poof, it gets erased. So what's left behind? What persists? The patterns that are stable enough to handle a flow of energy passing through them.
So, this brings us to our key term for this whole explainer, an entropy rider. This is any system, any pattern, that has basically figured out how to surf the cosmic wave of entropy. It channels energy from a high state to a low state, that's the gradient, and it uses specific rules or structures, its constraints, to do this without destroying itself.
And that gives us this simple, really useful 4-part template for persistence. It all starts with a gradient, which creates a flow of energy. That flow has to be managed by constraints. And if it all works, the result is persistence. The structure gets to stick around. This is the exact mental model we're now going to apply to both life and AI.
So, let's put this template to the test. And we'll start with the most obvious, the most successful example of an entropy rider on our planet, life itself.
So, following our template, the very first question we have to ask is, where is the energy source? What gradient is life actually riding on? Well, in biology, these gradients are very literal, very physical things. You've got the massive energy gradient from the sun, of course. You have chemical gradients inside our own cells that power everything we do. And you have resource gradients in the environment, like food and heat. This is the fuel for life. Okay, but how does life manage this constant, intense flow of energy without just burning up? It builds constraints. A cell membrane? That's a constraint. An enzyme that carefully directs a chemical reaction? That's a constraint. These structures are what organize all that chaos into the stable, self-maintaining pattern we call life. This reframes evolution in such a fascinating way. It's not really about progress or some grand design. It's just entropy's filtering process, but applied to things that know how to make copies of themselves. The constraints that work, the ones that help the organism survive and replicate, they get passed on. The ones that don't, well, they get deleted.
Okay, now for the big jump. Let's take that exact same mechanical template, gradient, flow, constraints, persistence, and see if we can apply it to the seemingly totally different world of artificial intelligence.
So you know the drill. Just like we did for biology, we have to start with the same question. What's the fuel? What is the gradient that an AI system is actually riding? See, for an AI, the gradient isn't a physical thing like sunlight. It's informational. Just think about the absolutely vast amount of unstructured data in the world. All of that is a form of uncertainty. And then think about our collective human desire to make sense of it all, to predict things, to get answers. That huge gap between total uncertainty and useful understanding, that is the gradient that AI feeds on. Of course, an AI still needs physical fuel to tap into that informational gradient. And this comes in a bunch of forms. The literal electricity that powers the servers, the incredibly specialized compute hardware, the massive data sets it trains on, and, of course, the economic incentives that drive its development in the first place. It's a whole ecosystem of energy. So if a cell has membranes and enzymes as its constraints, what does an AI have? Well, its constraints are things like the model's fundamental architecture, the billions of learned parameters or weights that guide its outputs, and all the safety rules and deployment systems we build around it. These are the channels that direct the flow of information. And this is where the parallels get even deeper.
even more surprising. When we look at how an AI is actually trained, what we see is a kind of high-speed evolution happening right there inside the machine.
The process used to train most of these huge models is called gradient descent, but you can really just think of it as a relentless microevolutionary process. It's constantly making tiny, tiny changes to the model and then filtering out, deleting the ones that don't help it make better predictions. And when you lay it all out, the parallels are they're astonishingly direct. In biology, you get variation from mutations. In an LLM, it's just tiny parameter updates. The fitness signal in nature is survival and reproduction. For an LLM, it's a loss function, basically a number that measures how wrong it is. Selection in biology is about who gets to reproduce. In AI training, it's about which updates reduce that error and get to stick around. The underlying logic is identical. But these systems don't just exist in a vacuum. To really understand what this all means, we need to zoom out and see how these different layers of entropy riders are stacking on top of each other. It's really a nested system, like Russian dolls. First you have life, riding on the physical energy gradients of the planet. Then you get human civilization, which emerges by riding on top of the gradients that life creates, things like agriculture, resources, even human labor. And now AI is emerging as a brand new layer, riding the informational gradients created by our entire civilization. And this leads to this incredibly concise and powerful summary. Each layer is just a system for organizing the flow from the layer below it. So AI isn't just riding a simple gradient. It's a pattern of organization riding on top of another pattern of organization. So what does all this mechanical talk about gradients and constraints have to do with bigger ideas like purpose or meaning? Well, this framework suggests something pretty profound. Meaning isn't some pre-existing cosmic truth just waiting to be discovered. It's what emerges from the things that manage to survive, the things that persist, the things that have an effect on the world. And this leaves us with a final and, I think, crucial question to chew on. If the underlying logic of persistence, that filter of entropy, is the same for biology and for civilization and now for AI, what does it mean for our future when all these different systems operating on vastly different speeds and on totally different materials all start to rhyme?